This is the second video for Unit 9 over gas law calculations. So the first thing I want to go over is what are the steps for solving gas laws. So the first thing that you need to do is obviously you need to read the problem, but you need to identify your variables. So that's one skill that I'm going to teach you while working out examples. The next thing that you have to do is extremely important, and that's check the units of the variables that are given. If they're not in the right unit, you're going to have to convert them. So I'm going to give you a guide, and it's going to remind you that pressure always has to be in atmospheres, volume always has to be in liters, and temperature always has to be in Kelvin. So if we are not in those units in the problem, you're going to first convert them, and then you can move on to the last step, which is to determine which formula it is that you need to find your unknown, which after you identify your variables is very easy, and then just plug in the numbers and do the math. So let's work out a couple of examples after I show you what the guide is going to look like. So here is what you're going to get in class tomorrow, the gas laws reference guide. You're going to be looking at this every single day when you're doing these calculations. So I just want to point out a couple of things that you need to know of. So here is the section that helps you with conversions. I have up here a reminder of what unit each of the variables needs to be in, and then below that it shows you how to convert out of the wrong units and into the right one. So for example, if pressure is given to you in millimeters of mercury, you just need to divide that by 760 to get it into atmospheres. Or for temperature, temperature is usually given to you in Celsius, so you just need to add 273 to that to get it into Kelvin. The next section is the formula section, and this is all of the gas laws that we're going to be using for these calculations. For this video, we're only going to be using the very first three, Boyle's, Charles, and Gay-Lussac law, and then the other three we're going to look at later in another video. So whenever I pull the formulas, I'm pulling them from your gas laws reference guide. And then the rest of this, you don't need to really worry about right now. That's going to be later on when we get into more complicated calculations. So let's go ahead and work out some examples. So we're going to work out 3 examples of gas law calculations. Not too concerned with you copying down the problems, but I do want you to write down the work that I'm doing. That way you have an idea of how to solve these. So the first one reads, you have a 2-liter balloon and it is taken from 0.75 atmospheres of pressure to 0.54 atmospheres of pressure. How big is the balloon at the new pressure? So again, first thing you need to do is read the problem and then identify your variables. So it says that a balloon is 2 liters large, and so that is your volume. And in these problems, they're always going to give you an initial state. Those are going to be the 1s. And then it's going to give you how it changed, the final state, which are going to be the 2s. So this is what our balloon started out as V1. And then it says that it started at a pressure of 0.75 atmospheres. So this is your P1. And then that pressure changed to be 0.54 atmospheres. So that's going to be your new pressure, P2. It wants to know how big the balloon is at the new pressure. So it wants to know the size. So that's going to be your V2. Remember, volume is how much space you take up. So we are given pressure and volume. So we're going to be using Boyle's law. And Boyle's law is P1 times V1 equals P2 times V2. So before we can use that formula, we need to make sure that we check our units. So volume is in liters, so we don't need to convert that. Pressure is already in atmospheres, so we don't need to do any of those conversions. So we're simply just going to pull the numbers from the problem and plug them down into the formula. So if you're one of those people that gets a little lost when you're reading your problems, you can go ahead and write off to the side what the variables are that were given in the problem, and then you can go ahead and plug them in. So I'm just going to do that real quick off to the side. So the very first thing is P1 times V1. So you're going to do 0.75 times 2.0 equals P2 times V2. P2 is 0.54, and then V2 is our unknown. So we're going to leave that as V2 in the problem. So all you need to do is get V2 by itself on one side of the equal sign. So in order to do that, this 0.54 is being multiplied, so to get rid of it and to move it on to the other side, you're going to divide by 0.54 on both sides. And so 0.54 will get canceled out on this side, leaving just V2. And so now all you have to do is plug your numbers into the calculator. 0.75 times 2 and divide by 0.54, and you're going to end up getting 2.78. And since this is volume, our unit is going to be in liters. And so that is using Boyle's law. Now before you move on, I want you to make sure that this makes sense. Boyle's law says that there's an inverse relationship between pressure and volume. So what happened is our pressure actually went down in this problem. We started out at 0.75 and went down to 0.54. So that means that the volume should then go up. We started out at 2 liters and it went up to 2.78. So that's just a way for you to check your answer and make sure that it actually makes sense. Okay, so our next problem reads, a balloon has a volume of 5.4 liters at 25 degrees Celsius. What will the volume be at 95 degrees Celsius? So I'm going to go ahead and identify my variables. I'm starting out with 5.43 liters, so that's my V1. And it gives me an initial temperature of 25 degrees Celsius, so that is my T1. Gives me, it wants to know the volume at a different temperature, so we're going to be looking for V2. And we're given a new temperature, T2. So we're given volume and temperature, so we are going to be using Charles's law. So volume is already in liters, so we're not going to have to convert that out. But if you notice, the temperatures are both in Celsius. So we're going to have to convert those before we plug them into the formula. So if you are looking at your reference guide in class, you see all you have to do is add 273 to both of these temperatures to get them into a temperature unit known as Kelvin. So 25 will actually become 298 and 95 will become 368. So Charles's law on your reference guide is V1 over T1 equals V2 divided by T2. So we're just going to plug in our variables into that formula, 5.43 divided by 298, and that equals V2 is what we're looking for, so we're going to leave that in there, divided by 368. So these look a little more complicated to solve than Boyle's law, but it's pretty easy. Your unknown is what you're trying to find, so how you can do that is you can cross multiply and then divide. So what you would type into your calculator is 5.43. Oops, it's going to be a multiplication, times 368, and then divided by 298. So cross multiply and divide, hopefully that's something that you've seen in math class. So you're going to end up with a V2 that equals 6.71, and the unit is going to be in liters because it's in volume. So let's make sure that that makes sense. Our temperature went up, so volume should also go up because volume and temperature have a direct relationship. So if you notice, our volume went from 5.43 up to 6.71, so our answer is actually making sense. Okay, so the next and last problem, a bicycle tire initially has a pressure of 120 psi. So this is our initial pressure, so that is P1, and a temperature of 25 degrees Celsius. So that is your T1. The sun comes out and the temperature rises to 35 degrees Celsius. So this is your new temperature, T2. What is the final pressure of the tire? So we are looking for P2. So all of those units are actually incorrect. So we're going to have to do 3 conversions before we can even bother plugging this into the formula. But the formula we're going to use is the Gay-Lussac law, which is pressure divided by temperature on both sides should be equal. So P1 over T1 equals P2 over T2. So before we plug those in, we're going to go ahead and convert. So on your conversion chart, it says in order to get out of PSI, which is pounds per square inch, and into atmospheres, just divide by 14.7. So all you have to do is do that very quickly off to the side. So 8.16. And then temperature, you're going to do this so many times you're going to get used to it. It is in Celsius, and you just have to add 273 to that to get it into Kelvin. And So 25 will become 298, and 35 will become 308. So now that you have all of those in the right units, now you can plug them in. So P1, 8.16, divided by 298 equals P2 we don't know, divided by T2, which is 308. So another reason I have you guys do this off to the side is because it's really easy to mix up the temperatures or to mix up the pressures. So it is good to write that off to the side so that you make sure that you plug the numbers in the right place in the formula. So just like with Charles's law, we're going to cross multiply and then divide to get our answer. So 8.16 times 308, and then you're going to divide it by the leftover number, which is 298. So you're going to end up with a pressure of 8.43 atmospheres. It wasn't specific in the problem, but it is implied that you want to give your answer in the same unit that was given to you in the problem. So we need to convert that into pounds per square inch. So just do the opposite. In order to go back into pounds per square inch, we're going to multiply it by 14.7, and that'll get you 123.92 pounds per square inch as your final answer. So let's make sure that that makes sense. Pressure and temperature also have a direct relationship. The temperature went up, so our pressure should have gone up. So as you can see, we started with an initial pressure of 120, and we ended up with our final pressure of 123. So that answer does actually make sense.